fumble between slides, I apologize. All right, so this talk's going to be about crisis informatics. And when I talk about crisis in this talk, I don't mean personal crises that we go through every day. I mean things like this. So earthquakes, such as this one that happened in Japan a few years ago, other natural disasters like Hurricane Sandy that hit New York a few years ago. Basically, these catastrophic human tragedies that result in major disruptions of our day-to-day lives. Now, within this domain, I'm particularly interested in crisis informatics. So my background's mostly in web search and data mining in a field called information retrieval. And so my interest is in making sure that during these crisis events, we have a very good picture about what's going on. So are we still able to consume all of the information that we regularly consume day to day? And so here I have a little definition of how I look at crisis informatics and how we look at making sure our systems are robust. Now, when we talk about crisis informatics, there's a lot of things that we can think about. Like there's mapping technology, there's databases of what's going on the ground, etc. But I'm particularly interested in a notion of situational awareness. So situational awareness means basically an awareness or a model of what's going on around me right now. You can think about this as being important to, say, an affected population. If you're in the middle of a hurricane or aftermath of an earthquake, you need to know where food is located, potentially where shelter is located, etc. Or you can think about this from the perspective of a crisis responder. A crisis responder needs to know what neighborhoods are affected by the natural disaster. They need to know things like this. Has transportation been affected? So are there roads or bridges that have been affected? Housing, what amount of displaced population is there in a particular neighborhood or immediately in the aftermath of a natural disaster? Power outages is also very important. So if people have power outages in the middle of a blizzard, this is going to affect the response. Food availability, of course, is super important and something that we all experienced during Sandy. And finally, health is obviously something that you need to be able to respond to. So this is just a tip of the iceberg. There's lots of other types of information that you're going to be interested in if you're in the crisis response community. And traditionally, when we talk about measuring whether or not these things are affected in the aftermath of a natural disaster, we look at things like this. So this is really boots on the ground data collection. If I'm a crisis responder, I might dispatch a responder to a particular neighborhood to assess whether or not the infrastructure is still stable, or I might begin to collect 911 reports to get a picture about what's going on in an environment immediately after a natural disaster. So these are all great, and they've worked for a long time, but given our modern perspective, we begin to notice things like latency. In order to detect whether or not there's a neighborhood that has been affected, you actually need to dispatch a physical vehicle, get some reports back, and then assemble your model of what's going on in the city. Furthermore, it doesn't really scale. If the geographic size of the affected region is large, you actually need to dispatch a lot more individuals to get a good picture of what's going on. So the perspective that we've been taking recently has been to use a lot of the online information in order to augment the traditional methods of doing situational awareness to get a clearer picture of what's going on. So when I'm talking about online information, I mean things like news reports. So oftentimes the media has journalists or who are either writing articles or tweeting in response to some potential news events. We also have online services where we can monitor to what extent people are, say, searching for different items in from different neighborhoods. Or finally, we have social media. If we can monitor, say, Twitter or Facebook, we might be able to assess whether or not certain neighborhoods have been affected by a natural disaster. So here I have some work that we did with colleagues in the Qatar Computing Research Institute, where we monitored a lot of the tweets that were generated immediately in the aftermath of Hurricane Sandy. And so these tweets were classified into different categories of information that they provided. So you can see in the aftermath of Sandy, we had a lot of individuals who were looking to make donations, for example, report information about the state of infrastructure or of transportation, etc. And when we dug deeper, we saw that the actual profile of the people making tweets or other social media posts about the events, you had a lot of eyewitness accounts, and you had a lot of news media that were generating the tweets. And so this gives you an idea that this is what we call citizen sensing. So this is using humans who are actually generating the content as sensors for what's going on the ground. Now this has been effective for tasks such as detecting the epicenter of an earthquake. So some researchers in Japan were able to actually use the geographic information in tweets to be able to detect where an earthquake happened purely based on the social media. Similarly, they were able to track a typhoon as it went over Japan using just social media information. So it's not to say that this is the only information that, say, a disaster response agency should be looking at, but it gives us some indication that there's information here that we should perhaps be looking at. Now, here's a pair of plots that I look at often, because I think it gives us a lot of different perspectives on this problem. So the top plot is the volume of news articles generated about the earthquake in Japan immediately after it happened. The lower plot has the query volume for people searching for information about the earthquake in Japan, again, immediately after it happened. Now, let me spend some time talking about the top plot. Immediately after an earthquake happens, you have a huge generation of new content. Okay, so this is information talking about the number of casualties, or if it's, say, a terrorist attack, potentially describing what happened or who the perpetrators were. But what's important to notice here is that a lot of this content is potentially unreliable. So we all know that rumors start spreading immediately after these natural disasters. It's redundant. So if I'm searching for information, I'm going to get the same article or the same modified version of the content over and over again. And it's in general just very dynamic. Unfortunately, at the same time that I have this really noisy and dynamic content being produced, I have this huge demand from users for exactly the information on that topic. So the users are stuck in this situation where the system is perhaps unable to cope with the instability of the content being produced and being served up rankings or content which is maybe not the best or maybe not the most effective. For those of you who have actually been through, say, Hurricane Sandy or other natural disasters, there's this process of refreshing information from your news website or collating information manually from news websites to be able to figure out exactly what's going on. There's not a really clear idea of what's happening. So back before the web, if you can imagine, we used to go to our neighborhood bodega or newsstand to get a highly curated list of content that we could then consume day to day. Now, increasingly today, our newsstands look like this. So we're generating really a ton of messages by every second, and our systems are right now not able to cope with this, at least in the online streaming news situation. Ideally, what we would want is something like this. So here's a timeline of updates about an event immediately after the event happened. So here I think is a Japan earthquake. So the reason I'm presenting this slide is that I want us to think about a system which would notify me about an event, updates to an event after it happened, and only with relevant and novel information, right? I don't want to get that same update about you know, the number of casualties of an earthquake or the magnitude of an earthquake every time a news agency publishes about it, because then I'd be getting tons of updates. I just want to get one update per new bit of information. I also want it to be relevant. I don't want information about somebody who's unfortunately lost their dog. That's important to that person, but perhaps not to me. And I want it to be timely. So I want to be able to detect this information as soon as possible after it happened. So in the natural language processing community, there's a subdomain called text summarization. And text summarization deals with the problem of given a batch of documents, say a bunch of documents all about a certain topic, extract out the relevant bits of information, usually as sentences, to give a high-level summary of what happens in those set of documents. So for example, if I did a web search for a certain topic, I might imagine using the top 10 documents and summarizing those into something that looks like a Wikipedia page. Now, these batch summarization systems are not really effective for this online scenario where we're getting this stream of news documents as we have in the disaster situation. So some colleagues of mine a few years ago developed temporal summarization, which refers to this task of this online summarization. So as a system is consuming one document at a time on a certain topic, I want to extract out the relevant and novel bits of information as soon as possible to present to end users. All right, so here's an example of, say, a naive technique of doing temporal summarization. So let's say I have an information provider like a news aggregator, and I say, I'm interested in the earthquake in Japan. Well, one thing it might do is find every document that comes into the system that is relevant to earthquake in Japan and broadcast back to me the title of that news article. And that's fine, but you can imagine it falling down if there's a lot of redundancy. So I don't want to get a million messages about the magnitude of the earthquake. It might also fall down if there's unreliable information. So if for whatever reason there's an unreliable news source in my feed, then I'll begin to get updates that could potentially contain rumors. So together with some colleagues a few years ago, we developed a system that used machine learning that was alluded to earlier in order to selectively get bits of information from documents as they're indexed. So instead of just getting every single document that matches these keywords, I want to get only the titles from, say, those documents that contain new information, contain relevant information, and furthermore, we're going deeper into the document so that if there's some relevant bit of information that I want to know about that wasn't in the title, it'd be able to detect that. And so these temporal summarization techniques were able to get significant improvements in performance over baseline methods that were using, say, automatic summarization. On top of that, it was able to get a more comprehensive picture. So the user was able to, because the document was going deeper into the ranked list, or deeper into the document, was able to get information that was not available before that was still important. So I want to highlight here that a lot of this research was actually supported by an initiative out of NIST called the Text Retrieval Conference, or TREC. So NIST has, for the past 25 years, been running these conferences to develop evaluation methodologies for information retrieval systems that has supported a lot of the IR research and text retrieval research in the academic community, but in close partnership with a lot of industrial researchers as well. And to a large extent, the developments that we've had in the online summarization work owes a lot to NIST and their initiatives. Now, one of the things that we, in hindsight, started to see when we were reviewing some of the errors in our system was that a lot of social media was not uniformly adopted across the citizens who might be affected. So here I have a quote from Patrick Meyer, where he notes that social media like Twitter might overrepresent data from, say, more affluent users, or and may underrepresent those from, say, less affluent people. And so this is a problem when I'm trying to design a system for crisis response that's intended to be intended to support a crisis responder who should not be focusing their attention perhaps on the more affluent neighborhoods. And the problem with consuming social media like this is that the situational awareness will be distorted because the upstream data is biased in some way. So we noticed this in crisis response and started to look around a little bit, and we found some academic research that confirmed that this was happening in other places. That, in other web search or pricing, you began to see situations where you had models which were biased because of the training algorithm or the data were actually biased as well. Now, increasingly we're beginning to see in the news media similar things. So we're beginning to see reports about algorithmic bias due to biased training data or other reasons. Now, like I said before, one hat I wear is crisis informatics, another one is working on web search. And when I think about web search, I think about the users I have there, and it's a pretty diverse population of users. And so there's a huge risk if I'm developing an information retrieval system, which is overemphasizing certain subpopulations of that group. Because when I think about my closest peers outside of computer science, I think about librarians. Specifically, librarians have a very, very nice code of ethics that they adopt when they're providing information to their patrons. And this is something that I've begun to think about a lot recently, which is to say that I should be thinking about the design of a web retrieval algorithm the same way that a librarian thinks about providing information to their patrons, insofar as I want to be providing equal access to my entire population of users, irrespective of protected attributes. So if there's certain populations that are overrepresented in my users, I don't necessarily want to give them more effective performance. And so I've been talking a lot to librarians about where they got their code of ethics and whether or not it applies to the web search scenario, but I'm beginning to convince myself more and more that this is actually appropriate. Now, there's three things that we need to think about when we think about applying this sort of standard to web search engines, and I list them here. The first is metrics. So when we design web search engines, we're all very quantitative, and so we want to be able to quantify what it means for an algorithm to, say, be unbiased or to be fair. The second is auditing. We need to be able to, at large scale, run experiments to be able to test whether or not the system is exhibiting this biased or unfair behavior. And finally, we need design. So this is given that I can now detect and measure bias or unfairness, how do I actually design an algorithm to be robust to these potential pitfalls? Greg alluded to some work at Google that was done, or that was published earlier in the month, and this is an active area of academic research. What I'd like to argue, and if you'll let me do so briefly, is that our success with NIST and with tracking the past perhaps suggests a way that we can advance the state of the art in terms of fair machine learning and fair online services. That perhaps we should be talking to the folks at NIST who are fantastic at measurement about coming up with guidelines for how to actually measure fairness and how to best audit a system either internally or externally to make sure that we're providing the best service to our end users. And yeah, I guess I can close on that and take questions now. Thank you.
How do we define fairness? So what could be a metric for defining fairness as such?
So currently within the, there's a community called the Fairness, Accountability, and Transparency in Machine Learning. And they're actively debating what exactly that looks like. Because there's lots of ways you can define it, and there's lots of ways you can even quantify it. Each of those has different trade-offs with each other, as well as with metrics, say, like accuracy or other ways of having system performance. I'm not comfortable committing to one definition right now, but only to say that we're actively discussing it.
What are some of the privacy issues that kind of deal with, especially when you say you have video?
Well, I mean, there's with crisis informatics specifically, there's this weird trade-off between privacy and I guess how much help you can get, right? So I would contend that for myself, during a crisis event, I'm more comfortable revealing some of my personal information, especially to a crisis responder, if it's going to help me get help, right? Perhaps that's different from my baseline privacy levels that I would have any other day of the year. So I think it's pretty complicated there. So I mean, perhaps your question was alluding to those complications exactly. I don't have a really confident answer for you right now, other than to say that it's not as black and white as your privacy settings should be the same during the crisis as they are outside of it.
To what extent do your systems that you're looking at, to what extent do the systems that you're looking at allow you to use voice input as one of the input mechanisms? That's brought with all kinds of difficulties, of course, but to what extent are you looking at that and can you handle that in your systems?
So with respect to summarization, we haven't looked at voice yet, but definitely with respect to search, it's again something that, yeah, we're looking at. The queries look very different. They look more like natural language questions, and so you need to apply different techniques for processing those queries, but yeah.
So for temporal summarization to work, you have to be analyzing news stories and social media posts in a ton of different languages. Are there technical challenges for natural language processing when different slang, different grammatical usage, different language, or how do you kind of reconcile those actually in information?
Yeah, absolutely. I mean, that's a huge problem, not just, like you said, going across different languages, but also dialects within a language. And this is another place actually where things like fairness or bias can come up. If your representation for language is overtrained on, say, one dialect of English, it's going to perform perhaps more poorly on minority dialects. And so this is a place where you need standards or systems for making sure that your say language modeling is robust across these things.
How are you dealing with the process of? How are you dealing with? You get information from smartphones and tweets and stuff, but how are you dealing to include information from cell phones, basic cell phones, which is people with underserved needs in cases of critical responses like this?
Yeah, I mean, in the research I've looked at, we've more or less assumed that someone has a smartphone. I think that's valid. That we should be looking at a broader range of devices, especially since smartphones haven't actually penetrated a lot of the world, even though they may eventually. Yeah, I mean, I think it's a fair criticism.
So to that point as well, you talked about getting social media as your input mostly. Have you considered also the use of what the gentleman from Johns Hopkins was talking about? Perhaps we have devices that are just keeping track of what's going on. Could you tie into those? And if so, would you provide them with more, a greater assurance level than you might say a social tweet? Certainly someone could say, yeah, everybody's going to die in 5 minutes, you're going to go, oh my goodness, there we go.
Mm-hmm.
But it might be absolutely false. Whereas a machine, a robot, would say, yeah, the temperature is 50, it just dropped to 20, now it's going to 10. That might be more reliable.
Yeah, absolutely. I think the more diverse set of data that the machine has access to, the more it can confirm whether or not a particular social media post or even its own sensor is reliable.
Would you give one more reliability than another?
This is something that, I mean, putting it on a machine learning hat would say that, well, the machine will learn which one's more reliable, right? But I think increasingly as cities become more and more smart, you're going to have these sensors deployed more extensively so that you can either rely less on the social media or you can actually do those checks and balances that you're talking about.
I have a question in terms of what is the role of government, civil society, and the private sector, and like where do you think we are in terms of institutional application, like with FEMA or with UNHCR or both here in the U.S. but also globally?
I think that's a great question. And I sell my own research short. I don't think it's ready for prime time quite yet for a couple reasons. One is I think on the metrics that we have right now, they're not performing as well as we'd like them to. But also, secondly, it's not clear to what extent the information that we're providing through social media analysis, for example, is adding value to what, say, FEMA already has. So this is something that we as a community need to figure out. Now, I think also this is one place where TREC can come in, TREC or NIST can come in to help us better audit these systems so that if you are a FEMA or you are a Red Cross and someone comes up to you and says, here's my latest, greatest social media analysis tool, you actually have metrics or you have a test bed to assess whether or not that's a good technology.